what happens if we multiply two numbers together and the answer is greater than any number that we can represent? In that case, we're going to overflow to either plus or minus infinity. But what happens if the number is really close to 0 and too small for us to represent? Well, in that case, we underflow to plus and minus 0. So in this video, we're going to see how we can implement this overflow and the underflow. So I'll get rid of my image here first of all. Now if you head up down to the resources section, you'll see the Excel spreadsheet there. So if you go and open that up, and you'll see that there's a tab there, and the tab's just called Sheet 1. So you can open that up and you'll have access to this tab here. Now, whenever we were dealing with an 8-bit for the exponent, we know that the numbers that we can represent are 0 to 255. So I've got the 0 to 255 range here in the first column. That only goes up to, in this instance there, that would go up to the 255. Now I've continued it on here, but if we were only dealing with our 8 bits, that's as many binary numbers that we would have. So of course we've said that we can represent those as a positive and negative by simply biasing it. That is taking away the 127. So that means that the numbers we can represent are going to go from minus 127 down to 0 and then all the way up to a value of 128. Now, whenever we are actually working within Logisim, we're working with unsigned decimals. Now, unsigned decimals is not the same as the bias that we have here. In an unsigned decimal, the highest bit becomes a signed number. So that would mean that the first lot of numbers here, 0 all the way up to the value of 127, those would all be our positive numbers, and they would just be the same here. So that 127 is the same as that 127. But whenever we get to the next value up, which is 128, then that highest value becomes a negative. So in that case here, we would have the number 1 with 7 nothing. So this here would be minus 128 because the highest bit is minus 128. Now to get to minus 127, we would have 1 and 1. So that would be minus 128 plus 1, which is minus 127. And then we would have this value here, which would be again minus 128 for this bit here, and it would be plus 2, which is minus 126. So you can see it's going to start counting down the way. So it's counting down in this direction here until eventually it gets down to the value of minus 1. So what we have to be careful is we don't get confused with what we're using for our biasing and what we're actually using in Logisim. In Logisim we're using the signed decimal. So we're actually interested in this column here. But now there's one other thing to take care of here, is that we've already extended the bits from 8 to 9. So if we extend the bits from 8 to 9, we're going to have values that are going to range not from our 0 to 255, we're going to have values that range from our 0 all the way down to 511. So you can see here we've got values all the way down to 511. So including 0, we've actually got 512 different values. So in that case, if we were to work out what the signed decimal would be for this, we would be able to range from 0 all the way up, and the 8, if it was only 8 bits, it would stop at this point here, and it would change over for 127, then go to minus 128. But because we've got 8 bits, we've got an extended range, and that was the reason for having that exponent extension. So this is going to go all the way up to 255, and then at this point it changes and it becomes minus 256, and then it works its way back down. So in order to avoid any confusion here, let's get rid of these first 3 columns, and we'll just hide those for the moment. So we know that these are the actual numbers that we're going to see in Logisim. And If we were to then work out what our normal ranges would be, well, we know that the value 0 is a special case, okay, that's just the value 0. And then the value of 1 would run all the way up here, it would be our normal range. So these are the exponent values. So our normal range would run all the way up to 128, which would be the special case again. So this would be our not a number and infinity. Now, at this point here, we would have a change from our normal range and we would head over into an overflow to plus infinity. Okay, so this is the change over at this point here. So this would be an overflow to plus infinity, but this overflow is going to exist all the way up till we get to this point here. And then beyond this point it goes negative again. So at this point here we then have the value of our underflow to 0, because it's really saying that the exponent value is minus 256. And we can't represent exponent values of minus 256 in our 8-bit exponent whenever we build our circuit in Logisim. So this is going to be underflow to 0 from minus 256 all the way down till we get to the point here, which is our minus 150. And at our minus 149, we're now in our subnormal range. And the minus 149 comes all the way down to minus 127. And then at minus 126, we get into our normal range of numbers. And this normal range comes all the way down to the value of minus 1. So that means that we're able to split up the values for our sign decimal in Logisim into our different ranges. So this is the range for our subnormal, which again was seen in a previous video. So we know the junctions between those ranges. So if we know the junctions between those ranges, we can then use those ranges and the junctions in order to try and work out a plan for creating an overflow to plus infinity and an underflow to 0. So now that we've seen how our number ranges work, let's go ahead and we'll see how we're going to implement this in Logisim.